All right. What do you say we go and learn a little bit about some polynomial operations, specifically multiplication? For this entire lesson, we're going to be using this thing called the distributive property, which is not FOIL, okay? FOIL is dead, okay? We buried it. There was a funeral. There were flowers. Somebody said some nice words. We threw some dirt on top of the grave, and we moved on, okay? FOIL is dead. We are not using FOIL. We are using the distributive property, okay? So we're going to work our way through a handful of examples where we use the distributive property, and I may go through and illustrate it different ways on different problems, just so you can kind of see different ways that you could approach solving a problem, all right? So hopefully this is just a really big review for most of you, but it is one of those really important skills that we need to make sure that we're doing. So the first tenet of the distributive property is that when we have a set of parentheses and we have two terms that are adjacent to each other, separated by those parentheses, the implication there is that we're doing multiplication. But we're going to be doing multiplication with every term inside the parentheses with the term that's outside of the parentheses. So this 2x squared is going to get multiplied by 3x squared and multiplied by negative x and multiplied by positive 4. All right, so let's go and take a look at what that distribution is going to look like. So first, if I have 2x squared times 3x squared, remembering what I should about multiplying monomials together, I'm going to multiply their coefficients together, and then when I multiply these variables with exponents, I just add the exponents. So 2 times 3 is 6, and x squared times x squared is x to the 4th. So that's the first term in my product, okay? The second term is going to be when I have 2x squared, and I multiply that by negative 1x. 2 times negative 1 is negative 2. And x squared times x to the 1st is x cubed. Rounding out my distribution, I'm going to take my 2x squared and I'm going to multiply it by 4. Well, 2 times 4 gives me a positive 8, and then there's only an x squared term there, okay? So the product of 2x squared and 3x squared minus 1x plus 4 is going to be 6x to the 4th minus 2x cubed plus 8x squared, okay? And that's, again, is using the distributive property, okay? If we're multiplying two binomials together, we're still going to be using the distributive property, okay? Like I said, we're not doing FOIL. FOIL is dead. Let it die. So if I'm going to use the distributive property with two binomials, the implication is that each term in the first binomial is going to get multiplied by both terms in the second binomial, okay? So one way that we can look about doing this is just using the distributive property, okay? So we can go 3x times 5 and then also distribute 3x to negative 2. So 3x times 5x results in 15x squared. 3x times negative 2 gives us a negative 6x. Okay, I've now run out of terms in the second binomial to distribute the first term in the first binomial to. So now I'm going to start distributing the second term, which is actually this negative 1. Negative 1 times 5x is a negative 5x. Negative 1 times a negative 2 becomes positive 2, okay? That a negative times a negative equals a positive. Then I need to evaluate the problem and determine where my like terms are. I have an x squared term here. I have an x to the first term, an x to the first term, and a constant. So let's combine our like terms. I don't have anything to combine with 15x squared, so it stays 15x squared. Negative 6x and negative 5x are like terms. They're both x to the first terms. So if I have negative 6 of them and another negative 5 of them, that gives me a grand total of negative 11 x's. I only have a single constant, so that's just going to be plus 2, and this represents my product between those two binomials, okay? So If we go and look at another example, okay, this is one where we have a binomial that's getting multiplied by a trinomial. And this is the reason why I want you guys to remember that FOIL is dead, okay? The acronym FOIL is only applicable when you have a binomial multiplied by another binomial. But the distributive property can be used regardless of the number of terms you have in a polynomial. Okay, I am going to show you a different way though. This way I call kind of distribution rainbows because it's kind of making those big arches across the paper. This one I'm going to go through and show you guys how you could write it out using what's called the box method. Okay, so in the box method I'm going to take the first polynomial and I'm going to realize that it has two terms. Okay, there's two terms there. My second polynomial is this one, okay? And I'm going to count 1, 2, 3 terms, okay? So what I'm going to do is I'm going to make a rectangle that is 2 by 3, okay? So it's going to have 2 rows and 3 columns. So if I go and draw that out, okay? It's not perfect, but let's be honest, neither are you. Okay, so let's go and say we're going to do 2 rows and then 3 columns. So I need 2 vertical lines. Okay, so this is a 2 by 3 rectangle. What I'm going to do is I'm going to take the terms with the signs in the first one and I'm going to put them here and here. So this is going to be 2m and this is going to be minus 3. Okay. For the second polynomial, I'm going to put those 3 terms, I'm going to list them up here. So this is 3m squared, this is positive 4m, and this is a negative 2. And what I can do here is I can multiply row by column to get all of my different subproducts here. Okay, so 2m times 3m squared, that product goes in this box. 2 times 3 is 6. M times m squared is m cubed. 2m times 4m, that product goes here. 2 times 4 is 8. And m times m is m squared. Over here, I'm going to say 2m times negative 2 gives me a negative 4m. Okay, now I can go to the second value, or the second term in my first binomial. So negative 3 times 3m squared is negative 9m squared. Negative 3 times 4m is minus 12m. And negative 3 times negative 2 gives me a positive 6. So what I can do now is I can look at these 6 subproducts and I can combine them so long as they're like terms. But here's something you should go through and notice. So long as your polynomials have been written in standard form, check this out. All of my m squared terms are in this diagonal. All of my m to the first terms are in this diagonal. Okay? So it's kind of easy to spot what your like terms are if everything has been written in standard form and you're using this, which we're just going to go ahead and call the box method. So if I go through and combine all of that, I'm just going to write the answer up here, and I'll do that in red. So we start off and we have 6m cubed. It has no other like terms. I have negative 9m squared and a positive 8m squared. Well, that's just going to give me a negative m squared. I have negative 12m minus 4m, which is negative 16m. And then I have plus 6 all by itself. So just plus 6. So this is another way that you can go and model multiplying 2 different polynomials together. Could you use distribution rainbows? Absolutely. Okay. On the last example, could we have done this one in a box and made it as a 2 by 2 box? Absolutely. Okay. Pick whatever method works easiest for you and just kind of be consistent with choosing that. It'll make it easier for you. The last example we're going to look at is what happens when we try and multiply 3 binomials together. Okay, and I want you guys to take a look at this over here. I want you to remember that if you have 3 things and you're multiplying them together, like a times b times c, the product is just a times b times c. You do not, I repeat, not distribute the first to the second and the third and then multiply those two things together. Otherwise, you would end up with a times b and a times c that you were multiplying together, and you have an extra a in your product that should not be there, okay? So when we do a times b times c, when we multiply three things together, just work your way from the left to the right and only multiply two things together at a time. So if I'm going to go and multiply a plus 2 times a minus 5 times 2a plus 4, I'm going to start by just multiplying the first two together, okay? So I'm going to multiply a plus 2 by a minus 5, full stop, okay? I will then, when I'm finished, go back and multiply that product by your 2a plus 4, okay? I want to block off the parentheses there. All right, so if I use the distributive property, a times a is a squared. A times negative 5 is minus 5a. 2 times a is plus 2a, and 2 times negative 5 is negative 10. Combining my like terms in the middle here, I'm going to get a squared minus 3a minus 10. And now I'm going to take that and multiply it by 2a plus 4, okay? So I'm just going to use the distributive property this time, but I'm going to go through and kind of stack my answer so you can see another way that I can go through and do it. So first I'm going to go and distribute this a squared to these two terms. So a squared times 2a is 2a cubed. 2a times 4 is plus 4a squared. Okay, next I'm going to multiply negative 3a. Negative 3a times 2a is negative 6a squared. The reason I've referred to this as a stack earlier is I'm trying to put in a vertical column all of my like terms. It's just going to make it easier to simplify at the end. You'll see. So then we have negative 3a times positive 4. Well, that's minus 12a. My third term in the first trinomial is negative 10. So now I'm going to distribute that to this the binomial 2a plus 4. So negative 10 times 2a is going to give me negative 20a. Again, like terms are all lined up. And negative 10 times positive 4 is negative 40. Okay? So if I go and combine all of my like terms, then I'm going to be able to write my answer as 2a cubed. This is going to give me minus 2a squared. These two like terms are going to give me a minus 32a, and just one like term here, so that's going to give me a negative 40. So that is what this product is going to be equivalent to, okay? At no point should you multiply this binomial and this binomial by this binomial, then multiply them together. Work your way from left to right. When you're multiplying binomials, or really when you're multiplying anything, you can only multiply two things together at a time. So chop the problem up so you're only doing two things at a time.